Alrighty then, hello, and welcome to the Train Buddy Shop. We're delighted to see you today. And we got another engine that should be a quick install, but this uses a DASR decoder. Now, every company makes this form factor, which is a flat board used for Atlas, and you can see all of the different engines that this goes into. So this is a fairly common decode situation. And let's get into it. I'm going to open this engine. This is made by Kato, and this is an RS3 by Kato. So let's get into it. Okay, the classical approach to many of these in today's engines is to take the couplers off. So we're going to take the couplers off on both sides and look for some screws down in here. Doesn't look like there's any, so this should fall right off. Be back as soon as I get the couplers off. All right, so this was a little bit tough getting the shell off, and one of the reasons is because they put some double-sided sticky tape on the sides of the weights. That's to keep them from falling out, obviously, but it hindered me being able to get it out. There's also, if you notice the way the lights are set up here, there's a single light right in the center of this. So when you're running analog or just DC on the track, this light lights all the time, and again, depending upon the voltage given to the motor, and different brightness, but it goes out both sides through the light pipe that's in here. So we're going to have to change that out. Because we're going to have to change the lights out. We need lights on front and back, and we're probably going to do LEDs. We're also going to probably cut back this light pipe on both sides, and maybe even do away with the metal reflector at the top, which is not necessary. The weights pretty much should stay the same, especially if we're going to just cut the light pipes back. You can see we cut the light pipes all the way back to here without too much problem. So let's get into it. The first thing we're going to do is take the rail from the trucks. We're taking the right and left rails off, and these just pull out. They're a little tough because they're made to stay on there, right? And we may even take those connectors off. So one of the other ways to do this is just cut those off. There's two little clips right here, right, that you push in, that holds the board on. All right, so push that clip in, push this clip in, and well, it should almost snap off. The only reason why it doesn't is because this is holding the motor straps. Those are motor straps. So we need to remove these wires to take the motor straps off. So it's kind of up and down, up and out. There you go, up and out, and then back this way, or out. Which way? It should be this way. Up and out. There you go. See, that one snapped right off. Okay. And oops, we have a problem. See, I was too rough with that. Okay, this snaps onto the top of the motor. Now, one of the issues here is that when it came out, it took out with it, right, some little metal piece. Not quite sure what that is. Oh, that's that plastic piece off of this. But here's the spring, right? There's the spring for the brush for the motor. So that has to go back in there. Hopefully the brush is still in there. We'll look real close and see if we can see the brush in there. Focus. Well, I'm going to set the spring down. Turn this upside down and see if the brush is still in there. All right, not quite sure where we left off, but here's the spring. We're still looking for the brush to make sure that we've got the brush. So I'm going to continue to look for the brush and test to see whether or not the brush is in there with something. And then I'll be right back. Okay, so I couldn't really tell. I mean, it looked like the brush was in there, but one of the ways to find out if the brush is in there is just put some power to it. So we're just putting some power to it, and the motor works, so we should be good to go. All right. Now, the decoder itself should fit in that space, and we see it right here, right? It's almost the same size as the piece that was taken out. And this is fairly common for these. Sometimes it's a green board like this with stuff on it. If it's Kato and some of the Stewart engines, they look like this. And again, this is a pretty much a throwaway analog version, and we're going digital. So be right back after I get it out of the package. Alrighty then. So the board itself is kind of cool the way it's designed. They designed it so that underneath there are two pads here and here, right, which then when turned over like this touch the tops of those and clipped in, right, touch the leads, motor leads. Now ordinarily you would bring wires out, and you could do this too, clip them off and bring the wires out and attach them to those two. Now the only, I guess, negative part of this is when you look at the documentation says, right, that this is the front. So these two motor leads, upper and lower, and it shows motor upper and lower here, right? So when we put it this way, right, this would be the head or the headlight. And if we look at the shell and the way the shell goes on there, that would force it to be short hood first, or short hood forward. In other words, going in this direction, right? So don't have much choice there other than we can reverse some CVs and maybe change the headlights back and forth. But anyways, if I go to put that on there, I look underneath, right, and those two leads touch. Now that's not a good thing, right? So what we're going to do is we're going to take and we're going to cut the leads back just a little bit so that they just touch the top. Now remember, in the old board, they were on top, right? And so one of the things you could do is you could turn it upside down like this, right? And then you could solder the leads on there, right? So if we look again at the documentation and how it's oriented, I'm going to reverse this. I'm going to turn it around here so that it matches what's on the diagram. It's always good to do that, right? So on the diagram it says motor plus upper. You can see it there, right? And again, I don't know if this board is upside right or upside down. It doesn't really tell us, right? It says the front of the locomotive and rear of the locomotive. You can see that, right? Does it say? Doesn't really tell us. I mean, I'm looking for some of these cuts that they're talking about. I don't see those either. But in any case, if I look at it this way, this would be the upper, and that's upper, right? Well, if you turn it over this way, that's not upper. That's the upper is up here. So I guess, again, orientation here. Looking at these two and where they are on this is the correct orientation, because if you flip it over, they would be in the bottom. Okay, so this is the correct orientation. This looks like on the diagram those are up on top. Actually, on some decoders they are. On this particular decoder, they're not. And it says this one, right, is the upper, right? And if we look on here, in fact, that's the upper one. Okay, so when this is set in there like this, that is correct. Okay, upper and lower. So they just kind of snaps in there, so I'm going to take my time and do that right. But remember, I'm going to cut these two back a little bit. You could fold them back too, but again, you would want to watch that you don't touch this lead to this lead, because that's upper and lower real close to each other. All right, be back in a second. Okay, so I snapped it on and they don't touch. Look, they're not touching. All right, so that's not any good. So I'm going to have to move these out, right? Move the leads out so that they touch the edge. They have to touch those contacts in order for this to work. I'd be better off soldering them, right? Because you want to make sure that they touch that contact edge. So just like that on that side, and on this side, this is the top one. This is the one we're having problems with, so I don't want to fool with it too much. I may want to take it off before I twist it. Well, I kind of hold it there while I do it. Am I touching it? Barely. Barely. Okay. Well, we may have to fuss with that. That may not have been a great engineering feat as I thought it would be. All right. It's touching, but barely. All right. And again, the same thing here. It's touching, but barely. All right, let's go ahead and get the right and left connected here. Some decoders, and you could do this too, just put a wire on here. If you look at the old setup, right, this wire is perfect. You could cut this wire off, crimp it, put it in through the hole, and then you could connect these without soldering. You just solder these to the hole and then put these on it, right? Or you can just solder this, link it all right to the decoder. So that's what I'm going to do, because again, I'm getting paid by the hour here. So I'm getting paid by the piece, so we want to do it as quickly as possible. All right, and I'll be back when we do that, and then we'll take it for a test drive. Okay, so after looking at it, it looks like these are not going to make connection on a reliable basis. So what I'm going to do is I'm going to drop solder on each one of those connections. So watch me while I do this, but hopefully my head's not going to get in the way here. But all I'm going to do is put some solder right there between the thing and the board. That's one way to do this, right? See if I got it. Maybe not. Let's try it again on this side. Now that looks pretty good. Now let's do the other one. Again, we want this to be reliable, so the only way to make it reliable is to, and I'm not real fond of these pressure connections here. There you go, can you see that? Now let's kind of zoom in on it so we can see what we're doing here. So what I've done is I've soldered the connection from the motor right to the decoder on both sides. Okay. Again, I could have run wires from each one of those up to the motor, but I guess that was the easiest way. All right, time to do a test run here. See whether or not we blew it up. All right, put it on the track. And the first thing we do is see if we've got any kind of connection here. So let's back out where we can see what we're doing. Let's go programming to PG, right? And we want to be at add to and display. Whoops. I didn't like that sound. So I'm hearing a which sounds like we're still connected somehow. So I need to go back and test and see why it thinks we're still connected. Hopefully it's not the motor that's connected to the frame. Alrighty, I've spent about a half an hour doing research on this particular engine. It turns out that there are no F marks on this. I don't see any on the, so we don't know which way this engine was running. As it turns out, the Alco units, some Alco units and some companies went to a great deal of expense so they could run it either long hood or short hood forward. There's pictures of the NCE, not specifically this number, but some other ones. I could look up this number, I guess. Running short hood first. And as we started out doing this, this was exactly that orientation. So I'm going to leave it at that. I'm going to assume this is the front. And so we're going to mark this with an F here, right? And say this is forward. So moving in that direction is forward. I'll tell you why that's important here now, because what I want to do is I want to hook up the motor leads, all right, so that it goes forward when it says forward. And the way to do that is to figure out which is plus and which is minus. So we're going to use an analog. We're going to use a bench power supply. Just put 3 volts on it. And I'm just going to arbitrarily pick one, right, and see which way it goes. Well, I picked correctly, right? So with this top one is plus, and the strap that goes to the bottom of the motor is minus. That means that this is orange, and this will be gray based upon the NMRA colors. So I'm going to go ahead and solder those on and be right back. Okay, so as you can see, I put the wires on and put some shrink tube around it. All right, so let's get up closer so we can see what's going on, right? And so this was where I had soldered before. I'm going to turn that over now, right? And we're ready to put those into the motor leads where they're supposed to go. Now, got to look at the diagram here. And of course the diagram is backwards from the way I got it set up. So I'll turn this around so I can look at the diagram. Right? And the diagram says motor plus upper, right? Motor plus upper goes to that one and minus goes to that one. So it should be orange is the upper or plus, and minus is the lower or gray. Okay, so it should go orange first to that one, gray second to that one, just like that. All right, I'm gonna go ahead and strip those, solder those on, and we'll be ready to put the leads back on from the trucks, and then we'll do a test. Be right back. Okay then, I cheated. Yeah, I cheated. I tested it before I got you set up here. So let's look. Here's the display. I'm going to hit the button, read, and there it goes, 03. So it's ready to go. We can go ahead and program the number. The engine number says 8866, 8856. Yeah, these NCE numbers are tough to read. 8856. Check on the board here. All right, so we're going to make it 8856, and so we go to push that button in, and we do 8856, and enter. And we hear the machine. I'm going to now push the button again, and you can watch and you can hear it move. And so it moves because the decoder, when it's asked, it uses the motor as a ballast. So that kind of tells you whether or not the motor's hooked up too. So we're good to go. Should be working on 8856. Let's go ahead and turn the layout, or turn layout power on this motor. Let's come up here. Let's get out of hitting exit, right? Gets us out of programming. We're going to turn this knob to get its attention. We're going to say loco and 885. Whoops. 8855 is not what we want. Let's go back again. Oh, and I hit 6 again. 9993. Okay, so now let's do it. 8856. Whew. Well, that was tough. Enter. All right, now let's check. I'm gonna turn the speed knob up here. I'm doing this with one hand while I'm trying to hold it with the other. Well, oh, it's not running. Why is it not running? Oh, there it goes. Whoop, 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 whoop. Stop. Go the other direction. All right. So it's running. All right, now the other thing we want to do while we've got it here is we can go ahead and go into operations mode, programming. So here, when we push the programming button, look right here in the center where it says PG, looks like PG or P6, right? Hit it again, it says PH, PD, and then PO. And then notice that the address of the locomotive, 8856, is up there. And that's important, right, that we get 8856 on there. And notice it went away when I hit hit the loco button. Bad. All right, exit out. All right, let's do it again. All right, program. PH, PD, PO, and there's the number, right, 8856. Don't hit any other button now. All right, we're going to now put this in for 3, that's CV3, and we're going to make this a 1. You should make it something other than 0, and we're going to enter. We're going to watch the loco move, or hear it move, right? It says okay or good. We're going to go 2, right? Hit enter again. All right, let's go back to 1 for 3. Now this is, yeah, whatever that is. Let's say motivation, no. Enter for 4. All right, makes it go slower, stop and go. We're gonna exit out of this, right? And we're gonna make it go, right? And then we're gonna hit reverse. And it's going to stop before it goes in reverse if you hit the momentum. That's the word I was looking for. I knew it started with an M. It wasn't motivation. Some people have momentum in getting motivated. All right, so there we go. So it's working good. We got a program for those other things. I lubricated it while I had it open, and we're ready to put the lights in. So be back as we get it back on the bench and think about how we're going to do that. Alrighty then, we're back ready to test the motor. Everything looks good. Time to look at the lights. So how are we going to do this? Well, we talked a little bit about the where'd it go? Oh, there it is. Talked a little bit about cutting the light pipe so that it would fit up in there. Let's see, does it go this way or this way? Yeah, what I'm looking at is the light pipe itself has got it's got a crook in it, and the crook goes one way or the other. So is it this way or is it this way? And depends upon if I do it that way. It kind of fits in there. What's this one look like on the other side? Yeah, okay, so it, for whatever reason, it bends up. It bends up. Okay, so now the question is, I get all this hanging together here. The question is, if I put lights here and here, that looks like those two are going to end up being like there and there, which is on the other side of where these connect here. I could put them opposed to each other this way, right? Again, cutting the light pipes back to about there, and then putting the opposing LEDs looking towards that. I could cut it all the way back to here, and put the LEDs up inside. All right, I'm thinking I'm going to look and see where these weights go. Oh, look, the weights have got some kind of like little special thing on them too. Ooh, I don't like the way that those metal pieces are so close to where the LEDs are going to come out. I may want to put some tape on those. Keep those from creating a problem. Okay. I can't really do much about how this fits in here. That gives me some idea about where it will end up being. Okay. Oh, it goes that way anyhow. Yep. All right. So about there. Now, if I put the LED up and over this way, it goes up and over, and I cut it off there, then it would go directly into that light pipe. But it would be right over that weight. Alrighty. Or maybe it goes, does it go this way? No, it goes this way because there's the nose. Interesting. Oh, and it's got a little spot there. It can't go any farther back than that. Okay, that's good. That's good to know. All right, let me think about this. Let me look at some other pictures online and see if I can get somebody else's idea of how they handled this. I'll be right back. Alrighty then, so I've looked at some documentation, and it looks like the best option, now this is not one that I've seen here, is to take the light pipe, which comes back through here, and I've got it sitting where the crook is, and then this is metal up to about that point. So what I'm going to do is I'm going to cut the light pipe right about here, if you can see that, And then the LED, I'm going to crimp the legs on it, put it right on the decoder so that it's right on the decoder. And then we're going to strip or cut the links that are over the resistors. So that it's got 1K resistors that are on the board. And we're going to cut those links, and I'm going to show you where to cut those because it's not quite so obvious from the documentation. So let me cut the light pipes here and be right back. Alrighty then, so the question is which way, so I've cut these, cut the light pipes to there, and I'm going to tack those down. I'm going to use some RTV, room temperature vulcanizing clear that I've used before, and I'll show you that in just a minute, to hold those in because they just flop around otherwise. Because I've removed the catch that was on there. That's gone now. So then let's take a look at the decoder. I want to put this LED on the decoder, so I need to know what's plus or minus. Okay, so we're going to look at the diagram. This is the diagram from the documentation, and it shows. Want to make sure these two pins are shown here, right? So it shows the output of light 1, and it shows light common. So light common is at the bottom. That would be plus, and then the top is minus. On this side, right? Light common is at the top. So on this side, plus is at the top. So plus on the bottom, plus on the top. And I'm just going to go ahead and mark those just with a pen, so I don't have to keep fooling with it. It may even be listed on the decoder. Yeah, it is listed on the decoder. It has a C here. It's hard to see, you can't see it, but there's a C there and there's a C up here. So common is plus. So when I do the LEDs, I'm going to do the LEDs so that the long, which is the plus, right, goes down this way on this one. So we're going to go ahead and bend that, right? And then we're going to put those in there, and I'm going to solder that in. We'll have to shorten those leads up considerably, right? And we'll solder that in so that it's just at the very top of that. All right, and I'm going to cut those back and show you just a second. All right, so there you go. And if you look at this, you'll see that if I take the light pipes, let's have to take one out. Oh boy. Yeah, take the light pipes out, and we'll put this one in just so you can see what's going on there. So there's a distance here between here and the light pipe. The lenses would come out here, and there's a distance between here and here, but when you see how bright these are when they're working, it won't make a difference here. Now, here's the key, and this is kind of where I was confused with what was going on here. If you look at this diagram, it says, let's see, I turned it around again. Let's turn it back around, where this is like it is on the diagram. It says, link bar strap. I guess that's what that is. Let me see. It's a link 4. Wow. Link 4 output 3. Link 4 output 1. Output 4, 5, and 2 is over here. Now what they're talking about is it doesn't look like, well, it does look like that if you look real close. So we're going to look real close, and I'll show you what they're talking about. Let's see if I can get it to focus is the problem. Come on, focus. Well, I can't focus it and hold it at the same time. There we go. And this doggone screwdriver is so big. Now let's get a really tiny screwdriver so I can point to this. All right, now, do you see that? See that green? Looks like square over top of this, right? Well, that's what you got to cut. In other words, you got to cut through the green outer membrane and through the copper right there. Now, that's a 1001. That's 1,000 ohm resistors, what those are, surface mount resistors. And again, this is going to be a little tough to do, but you can see where the line is, comes right through to this resistor. So this is what I want to cut right there. And on the other side, right, I want to cut that one right there. That's for output number 2. So I'm going to cut those. And how I'm going to cut them with is I'm going to try to cut them with an X-Acto knife or even a screwdriver. I'm going to try to scratch through there. So it's not going to be pretty, but I just have to scratch through and cut those. And I'll come back and show you after I've cut them. All right, so I've cut these, and again, as I said, they weren't going to be pretty because they are tiny, tiny, tiny. Now, I started off by using a screwdriver. That did kind of okay. Then I went and I used a jeweler's file, used the tip of the jeweler's file, and just kept scratching at it. And what I wanted was I wanted to be able to show, right? So using a continuity checker, let's get that continuity so you can hear the beep, right? Now I'm going to do the one above it, which hasn't been cut, right? So that one hasn't been cut, and this is the one that I cut, right? And so that shows that I've cut it, right? Do the one below it, right? Shows not cut, all right? Then I'm going to go back over here to this one, which is the other end, and we're going to test it, make sure that it's cut. And it is, right? And if you wanted to test it even further, what you could do is put your meter on the 1K measurement. So I'm going to try to get the meter in the screen here, right? And then push this up maybe. Okay, and then measure across these devices again. And it shows 0.998. Yeah, it's hard to see, right? 0.997 there, which is 1K. All right. So that's how you test it to make sure that it's, again, you have a resistor in there and you have cut that. Because if you don't, when you go to put it on the track, it's going to blow up and blow the LED up. And some people said, oh, it worked for a second. Yeah, that's right. And then it blew up. All right, now let's go over to our track. And again, we're going to run a test here. Make sure that the system is on. Let's go back out here a little bit so we can see what we're doing. Come on, come on, come on, back out, back out, back out, all the way. There we go. Now, let's turn our system on, and our number was select 8856 loco. All right, now let's test. Is that it? Yep, that's it. Okay, now let's see if we got lights. 0. Oh, yep. All right. Reverse. All right. Engine's not on the track. Hold on. That's on. That's on. Not making good connection. Well, At least it works and the lights are on. Good, 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 good. All right. Let's go back to putting it in the shell. All right, so the next thing we want to do is we want to protect the LED and the decoder from this weight backing up into it. So I'm going to put a piece of tape around the end of this. We use Captain tape here for the most part. And again, a dialogue on Captain tape is not necessary at this point. We have some other videos that talk about it. Okay, so we're just going to put some Captain tape on the ends of each one of these, like this, over the edge. Over the edge like that. And the Captain tape should stick to the metal, right? If it doesn't, it's because the metal's not clean. It's got some grease on it or something. So, and then we'll cut that, form it. Be right back. All right, so this is a new tube of Permatex clear RTV silicone adhesive sealant, and I got this at an auto parts store. And so this is what I'm going to use to set these light pipes in with. All right then, so we're going to let this set up overnight, and we'll finish it tomorrow morning. So have a good evening. Alrighty then, so we have the top back on, and we're about to test it out. Let's see what we got here. Oh, the lights look really good. Let's see what happens here when we move it. Oh, okay, so two things are happening here. First of all, the lights are in the wrong orientation, right? And we got something hitting somewhere, making some funny noise. So we're going to take the shell back off again and take a look. And we're also going to have to change the CVs on this and figure out how to change the CVs on this to reverse the lights. Let's see. Actually, what we're going to do is reverse direction, because on the display it shows going in reverse and that going forward, and as we talked about, forward should be the headlight. So the light is right, the motor's going wrong. So a couple things we could have done. We could change the wiring plus and minus. I thought we had figured that out, but evidently we didn't. Or the documentation is wrong. Hello. Any case, we're going to pull this and see what's going on. I suspect the only thing that it could be is the wires that I used for the LEDs are too far in. Anyways, we'll tear it apart and see what's going on. Alrighty then, so I took it apart and I did a little bit of lubrication, for whatever reason, it seems like the weights were creating some problem. Don't know. Again, after I lubricated, things seemed to go away. So maybe it was just dry lubrication. Whatever, it works pretty good now. Now we want to change the reversing, and we want to reverse the direction of the motor. Now, I could go back in and change the plus and minus, just reverse the motor leads, the orange and gray lead. That's one way to handle it. The other way to handle it is with the CVs. So we're going to do that on this particular one. Notice 29 is 38 if I display it, right? It comes back and it says it is 38. Now if we just change it to 39, right, and we enter, now what we have done is we have reversed the direction of the motor. So if I exit out of this, right, and pick up that engine, we'd already had that engine in there, right? Now let's take a look at it and see what's going on. Light is on, right? The system says that's going in the forward direction. As we said, forward direction is short hood first, right? So the light is still in the reverse direction. However, the direction of travel is correct. So now we have to reverse the lights, and if we look at the documentation, it says that we can do that by using CV120. So 120 is output 1, 121 is output 2, and reverse forward, notice, is bit 1 and 2. So if I look at 120 and I look at 121, all I want to do is reverse those numbers, whatever they might be. So if I'm going to go now again to go to program mode, go to PG here, right? I'm going to make this 120, so I can either rotate the knob or I can just punch it in 120 and say display, and it says it is a 1. If we go to 121 and display, it says it is a 2. So what we're going to do is we're going to make 121 1, enter, and we're going to, whoop, no ACK, what? Enter. Good. Okay, and 120, we're going to make 2. Right? Enter. There you go. Now, that should have fixed that. But if I look at the documentation, I'm going back to the documentation. I'm trying to do all this with one hand and use the camera with the other. One of the interesting things is it says that 128 is LED. So if we go back here and take a look at LED, right? What it says is, let's see, add 128, right there, add 128 if you're using a white LED. Note the ditch lights effect will not work properly if made directional. So let's pick 128 to 120 and 121, CV 120 and 121. So let's see, how did we do that? Okay, 120 is 2, so if we add 128 to that, it should be 130. So we're going to make this 130, and just rotate the knob right till we get to it, or we can punch it in the system. Either way works. 130. There we go. And we're going to hit enter. All right, and we hear it click. Good. And 121 was, let's display it, was a 2. Oh, I did it backwards. Okay, this should be 130. So 130. Yes, I make mistakes too. 130. Enter. Okay, and 120 should be 129. So if we go, it should be 129. Enter. That was 1 plus 128. All right, now exit. All right, let's run our test. All right, so it says we're going forward. So we're going forward. We have the light on up here, 0, right? Light on. We look over here, no light. Let's try that again. Nothing. The light's on over here, going forward. That did not change it. Okay. All right, so what did I do wrong? If I hit reverse, well, that light came on. Did I do that wrong? I guess I did. All right, let's go back, new program again. You already knew that, didn't you? Yeah. 120 should be, let's see what it is now. 120 is, come on, there, 129, and it should be 130. Well, it was right the first time. All right, enter. All right, and 121 should be, let's read it. Should be 130. It says 130. That's what's in there, and it should be 129. Should be what it is. All right, now let's go back and check it again. Here we go. Let's see. Our system says we should be going forward, which means the forward light should be on. Ha! Finally. And as we turn it, yes, short hood first. Reverse. Yes, we're in good shape. All right, now to clean it up and get it ready for the customer. Thanks for watching. You can be sure to subscribe. Thank you very much. See you next time.